The purpose of this exercise is to teach you how to use the linear regression tools in Excel. The problem in the book states that Company P, the large manufacturer of paper products, was asked by one of its retail clients to provide an analysis on the role that shelf space plays in the sales of the product. The marketing manager of a large retail chain that purchases paper products from Company P has the business objective of using shelf space most efficiently. Toward that goal, she would like to use shelf space to predict the sales of a specialty paper plate product. Data collected from a random sample of 12 equal-sized stores are presented in Table 8.5. And you have been asked to use these data to answer the following questions. We must produce a line-fit plot to demonstrate the trend in shelf space and sales along with the predicted path. We must decide whether there is a strong relationship between shelf space and sales. We must look into how much shelf space accounts for the variation of sales. Discover whether there's a significant relationship between shelf space and sales. Develop a linear equation for predicting sales given the shelf space. And then predict the weekly sales of the specialty paper product for stores with 7 feet of shelf space for the paper product. I have entered into Excel here the data from Table 8.5 that show the random sample of stores with their shelf space and their corresponding sales in the thousands. In order to answer the questions in the textbook, we must run a regression in Excel. To do that, we go up to the Data ribbon and choose Data Analysis. From the menu of options, we scroll down and choose Regression. Now we must enter the necessary information into the boxes. For the Y range, we want to tell Excel what our outcome variable is. Our outcome variable is sales in the thousands. For the X range, we want to input our predictor variable. Our predictor variable is shelf space because we would like to use shelf space to be able to predict the sales in thousands. We will need to check the box for labels because we've included labels in the data range, and we've done that so that they'll be depicted in the graph that we produce later. We also would like to check the box for the 95% confidence level and indicate that we would like our output on a new worksheet ply. We also want to make sure the box for line fit plots is checked. And once we have all of this information entered into the boxes, we can click OK. The information will then open up on a new worksheet ply as we've instructed Excel to do. We can see that we get some regression statistics along with other values, as well as a line fit plot for our data. Question 1 in the textbook asks for us to produce a line fit plot to demonstrate the trend in shelf space and sales along with the predicted path. The blue diamonds in the graph represent the actual data points that we entered from Table 8.5. The orange squares are the predicted sales based on the regression statistics from this problem. There appears to be a positive trend or an upward trend in the data, and we can introduce a fit line to the graph to be able to see this more clearly. To introduce a fit line, we click on the green plus sign to the right of the figure and check that we would like to add a trend line. Now we can choose to add a trend line for the actual sales or the predicted sales. We're going to choose the predicted sales so that the fit line that's put into the figure will represent the regression equation that's been produced in the output. When we click OK, a line of fit is drawn through the orange boxes, which again are the predicted sales. So we can see even more clearly now that there is an upward trend in the data. This means that as shelf space in feet increases, so do the sales in thousands. So more shelf space is related to higher sales. Question number 2 in the textbook asks us to determine whether there is a strong relationship between shelf space and sales. To understand the strength of the relationship, we can look at the multiple R in the regression statistics table. The multiple R is 0.837. And because this is close to +1, we can say that there's a fairly strong positive correlation or relationship between shelf space and sales, which again means that as shelf space increases, so does sales. In order to tell if this relationship is significant, as question 3 asks us to determine, we have to look at the significance F in the ANOVA box. The significance F value is quite small. It's 0.00068, and that's much smaller than a requested alpha level of 0.05, which indicates that there is indeed a significant relationship between shelf space and sales. Our next task is to develop a linear equation for predicting sales given the shelf space. To do this, we'll need to locate the intercept and the slope for shelf space. These values are located in the third table of the output, and we can see that our intercept is 141.324, and our slope is 7.901. Therefore, our regression equation is y, or the predicted sales, equals 141.324 plus our slope of 7.901 times x. So that means that given some x value or some shelf space value, we can enter it into the formula and predict the sales. And that is precisely what number 5 asks us to do. The question states that given a shelf space of 7 feet, what can we expect the predicted sales to be? To figure this out, we simply plug 7 feet into our formula as the x value. So we do an equation for y equals 141.324 plus 7.901 times 7. So when we put 7 into the formula for shelf space, we get 196, which represents the predicted sales in thousands. So we can expect that with 7 feet of shelf space, we will have around $196,000 in sales. And that is how you can use the tools in Excel to do linear regression.